wrote this question up here above my head, what is statistics? I don't know that I thought about how to answer it that well. And I've been sitting here thinking about that question, and I decided to take this approach. I decided that, what do I think if I ask 10 statistics teachers that question, based on my experiences and going to conferences and working with colleagues and things like that, what do I think would be what would I think those responses would share or have in common? I think that they would all have something, say statistics has something to do with data and the need to collect data and the need to collect data in appropriate ways. And I think that probably all 10 of those statistics teachers would say something about computation and the need to do computations and the need for technology and to learn about the appropriate technologies. And I think the other thing that may come up is, well, I'm not even sure if there's what other commonalities there would be after that, honestly. But I think I'm going to approach the question differently for you, and I want to approach the question from this point of view, which is, what do I hope you take away from this class? What I hope you take away from this class is an appreciation for a discipline that I found very fascinating, but also very important and very useful in how we can apply mathematics to the real world. And one of my big goals for this class is to give each of you a new way of looking at the world, in thinking critically about the world. Much of the information that we get these days is in some form of statistics, some kind of statistical analysis, and computers are everywhere now, and data is becoming abundant, and it can get very confusing. And a lot of important decisions are made based on statistics. So I think it's really important to me to build a conceptual understanding of the ideas in this course. Things like, the need to assess, when we make a decision, the need to assess the appropriate kinds of error and why that's important and why that establishes credibility. But as we enter into this, as I start to get into the kind of the meat of the course, I want to initiate the whole course with the following video. And this video comes from a TV show actually called Mythbusters. And my kids have gotten me hooked on Mythbusters. And they do a lot of really cool stuff. And they actually do, they don't talk a lot about numbers. They allude to statistics sometimes and number crunching. But this particular this particular segment they did fascinated me when I watched it. And it's actually about quite a famous statistical question, probability question, really. And it was first posed to a woman named Marilyn Savant. And Marilyn Savant wrote for Parade magazine. She had a column. It was Ask Marilyn. And she had a really high IQ and seemed to know a lot of things about a lot of different things. So people would write in and ask her questions. And so somebody wrote into her once and asked her about the Monty Hall Show, which is this game show that was on TV when I was a kid. And the question was, I'm going to show you the video so you can see the details. The question was really about a strategy and which strategy was the best strategy. And I'm not going to go through all of this right now because it's all in the video I'm about to show you, but I think the thing that's interesting about that part of the story, where the whole Monty Hall, what we call now the Monty Hall paradox, where it really came from, was just somebody that wrote into her and asked her a simple question, and she actually gave the right answer to that question, and in terms of strategy, and she got like 10,000 letters from people all across the country, some of them math teachers and professors even, that said, you're wrong about that, doesn't make any difference whether you switch or not. So in any case, Mythbusters got into this, and I thought it was really useful for this course, so I want to show this little video, and then we'll talk some more about it.
Step right up for a viewer request extravaganza.
What's this about?
Well, this is the Wheel of Mythfortune. And each one of these boxes is a suggestion from a fan for a story we should do. Give it a spin.
Dear Mythbusters, can you please test the Monty Hall paradox from the game show Let's Make a Deal?
This is great. I know you're a big fan of game shows, but let me remind you what this one is. Monty Hall offers a contestant a choice of one of 3 doors, says there's a prize behind one, and the contestant chooses, let's say, door B. Before he gets to see if there's a prize behind that, Monty opens up door A and shows him that there's nothing behind it. Monty then offers the contestant a chance to switch from his original door B to the remaining door C. The question is, should you switch? Now, this is interesting for 2 reasons. One is that apparently psychological people do not want to switch from their original choice. 2 is, apparently, they will win more often if they do switch.
Wow. Well, I'm not sure why that would be the case, but let's test it.
It's unusual that a complex mathematical paradox is named after a game show host. But this counterintuitive problem has puzzled number crunchers for years. After a door selection is made, the host always opens one of the remaining 2 doors and then gives the contestant a chance to stick with their original choice or switch to the other unopened door. Which leaves us with a 2-part myth. Supposedly, people overwhelmingly decide to stick, and apparently, it's better to switch.
So how do you want to go about this?
Well, as far as I can see, there's 2 parts to the story. One psychological and one statistical. The psychological being that people do not want to switch from their original choice. The statistical being that there is an advantage to them if they do.
Well, let's start with the psychological then.
Perfect. So, let the games begin.
If we're going to test this out on the general public, we should get a bunch of people, say 20 or so.
20 sounds like a good number. How do you want to run them through it?
Well, we could do it with, say, a deck of cards.
I feel like that's missing something essential to a game show experience that may influence people's decision making. So I'm thinking a real stage and some real doors and set up a Mythbusters game show scenario. That looks great. And with their pre-made props in tow, the team's mathematical mission begins at a local theater. Ladies and gentlemen, door number 1, where they prepare their game show setting, which includes the obligatory over-the-top game show host outfit. Ta-da!
Maybe you should try door number 3. Much better.
Now shall we start?
Yeah.
With Adam dressed for the test, let's find out exactly what the test is.
We've got 20 volunteers, and the door behind which the prize has been placed will be determined by a computer-generated randomizer.
The psychology of this myth is what we're investigating with this test. It is stated that most people, if given the choice to switch their door, will not do it. We want to find out if that's true. We're going to bring in a bunch of contestants, run them through the whole test, but what we're really looking for is to see how many stick with their original choice and how many switch. We are playing a game today called Pick a Door.
Okay.
I would like to start this game by you telling me which door is your choice.
I will take number 1.
Number 1. Door number 1 is your choice. Jamie, will you please show Brian what's behind door number 3?
None.
As you can see, there's nothing behind door number 3. For those of you playing at home, there's an important fact you should know, which is that whenever I open an empty door for the contestant, I know where the prize is, and I'm showing them an empty door on purpose. Your prize is either behind door number 1, your original choice, or door number 2. I'm going to give you one last chance. You could switch right now to door number 2 if you'd like, or you can stick with your original choice. And so, to the moment of truth. As per the first part of the myth, will he stick, or will he take the opportunity to switch?
I will stick with my door number 1.
You will stick. All right, how come?
Because it was my first instinct.
There it is. Contestant number 1 sticks, and Adam and Jamie have their first data point. Jamie, will you show Brian what's behind door number 1? Sorry, there's nothing behind door number 1. Thank you so much for playing. That's an excellent data point. Have a good day. Thank you.
With no pre-knowledge of the test, from backstage, the next contestant steps out. You? And after picking her door,
Which door is your choice?
1.
Jamie opens up a losing door, and Adam moves the test along to the relevant data point.
You can switch to door number 3, or you can stick with your original choice. What's it going to be? Are you going to switch or stick?
I'm sticking
You're sticking. How come?
because the door is pink.
Okay, this time sticking pays off.
We have a winner.
It's a winner! Congratulations.
But remember, the win-lose result is irrelevant in part 1 of the myth. We're testing the psychology of the decision-making. Is it true that the contestants will predominantly choose to stick?
I'd like to offer you one last chance to perhaps switch your choice to door number 3 or stick with your original choice.
I'll stick with 1.
You really want to stick?
My
How come?
gut feeling.
Gut feeling?
That's 3 from 3.
I'm sorry.
And as the 100% record in favor of the myth continues,
I'm still going number 1.
things start to get really interesting.
I'm going to stick with You're going to stick with number 2. Is there a reason behind you wanting to stick?
First choice.
Because it's not just the score that's providing a pattern,
I'm going to stick with 2.
Sticking with 3. I'd like to stick with my original.
You're going to stick.
but the motivation for sticking is becoming clearer.
I'm going to stick.
You're going to stick. How come?
I guess it's a 50-50 chance.
The perception is that with 2 doors left, there's a 50-50 chance of winning. And so there's seemingly no advantage to switching.
You know, I trust my instincts. I'm going to stay with door number 2.
And incredibly, as every single contestant decides to stick,
I'm going to stay with 3.
part 1 of the myth is looking great.
Dude, this is so cool. They are all of them sticking with their original choice.
I know.
It's so cool. I would not have called that.
You stick with number 1?
And to fully decipher the results,
I'm going to stick.
Adam and Jamie roll their game show credits.
Fantastic. Congratulations.
Thank you.
Thank you so much.
And head back to the shop.
So I found this video really amazing because really I think the first place to start in a stats class is to start thinking about the psychology of decision making. And in this example, I think it's just really interesting that 20 out of 20 of these contestants chose to stick with their first choice. And they gave reasons like, this is my first instinct, or I have a gut feeling, and things like that. And later in the show, we find out, or Adam I think mentions that the perception is that there's just a 50-50 chance once they're down to 2 doors. Well, it turns out that's not the case at all. In fact, if the contestant chose to switch, they would double their chances of winning. That's a probabilistic fact that I can prove to you. And we'll talk about this again when we get to chapter 7. But again, I think it's really interesting in a first lecture to think about, individually think about how do I make decisions, and open your mind to a new way of thinking about how to make decisions. And it doesn't necessarily mean statistics is better than your gut instinct, but what it means is it's a different kind of decision-making process. Now, the other kind of getting into how we make decisions with statistics, and what I'm really starting to talk about in this first lecture is what we call inferential statistics, taking information or data from some population and then trying to infer some truth about it. And there's, in statistics, and in this, especially in this part of statistics, there's really a number of elements that we have to think about. For example, we frame the question in terms of a dichotomy. Examine the evidence assuming the null is true. If that evidence is deemed to be extremely rare and unusual, then it calls the null assumption, and what we call the null assumption, into question. So one of the examples I like to start off with, so that's part of it, and then there's also mathematics that comes along later on. And we use the mathematics to calculate probability. So it's important to understand probability to understand statistics. So and I'll talk more about that in detail as we go through the course. But the first hypothesis that I like to pose to my students, I call the Bigfoot hypothesis. And being that College of the Redwoods is located in Humboldt County, and the term Bigfoot originated here in Humboldt County, and since the question of whether or not Bigfoot exists is such a natural question to pose statistically, I'm going to start off with this as my first example. So a man named Jerry Crew, who was a logger working out in the woods in Humboldt County, discovered these footprints. And they were huge, and he kept coming back to town. And there's, again, if you're interested in this whole thing, you can find the story. It's on the internet. Back then, the time standard was called the Humboldt Times. So anyway, this logger named Jerry Crew found these large footprints and made some casts and brought them back to town. And most people, I think, thought thought it was a hoax. That it couldn't really be, there's no such thing as Bigfoot. That was sort of like the prevailing point of view. But the reason that I want to explain why I think this makes such an interesting statistical kind of question, and a way of explaining how the statistical decision-making process works. So we could start off here with the question. And our question is, does Bigfoot exist? This is our question. Now, it turns out that question is either, the answer to that question is either yes or no. In other words, we might say the null hypothesis is that Bigfoot does not exist. And then the alternate assumption could be that Bigfoot does exist. And notice that this gives us the structure and framework for a statistical hypothesis. So statistical hypothesis is always two parts. And there are two things, there are two dichotomies. They're a dichotomy. And what that means is these things can't both be true. In other words, Bigfoot does not exist and at the same time exist. Bigfoot either does not exist or Bigfoot does exist. Now, the way this whole thing works is that we're going to assume that H0 is true. And that's always the case. Okay? So we start off by assuming the null hypothesis is the one that's true. And in this case, that certainly makes sense because I believe the prevailing point of view on whether or not Bigfoot exists is probably that Bigfoot does not exist, at least among scientists in the scientific community. So then we examine the evidence. Now, in statistics, that is usually the evidence I'm talking about is usually data, information that we can gather from the population by assuming the null is true. And so in this example, again with Bigfoot, remember we're assuming that H0 is true. In other words, and that means there is no Bigfoot, so then we could establish what our expectations are. So what do we expect if the null is true? Well, no tracks. There would be no Bigfoot tracks. No eyewitnesses. Etc. But what I want to focus right now on is the track concept. The fact that if the null is true, then Bigfoot's not out there in the woods anywhere making tracks. But this guy Jerry Crew I can't remember, I think it was late 50s, early 60s, Jerry Crew found a track and cast it, and that track was 16 inches long. So, again, assuming the null is true here, either we're dealing with a hoax, which is possible, certainly, or a human track. So, if evaluating whether or not this is a hoax is difficult, and it's actually difficult to do with statistics, because when we do statistics, one of the things we need is a variable. And when I examine whether or not this could be a human track, when I look at the question from that point of view, then I have a data value. I have a 16-inch track, and I can say something like, I can define the variable. I can say let x equal the length of a randomly selected, and you're going to hear this phrase randomly selected over and over again all semester, but this is the length of a randomly selected male human footprint, I guess, or track, whatever we want to call it. All right. So then we have a data value. We have x equals 16 inches. So, the way this works is we evaluate how likely it is that this track would have been left by a male human. And the way we do that is we think about what proportion of the population of male humans leave footprints at least 16 inches long. That's how we would think about the null statistically here and examine this particular piece of data using statistics. And this is where the math comes in. So we have the philosophy, which is this dichotomy idea here, and the idea that if the null is true and I find evidence that's very rare and unusual, assuming the null is true, the philosophy is that if that happens, I should reject the null in favor of the alternate. And if the null is not true, the alternate must be true. That's because it's a dichotomy. In any case, getting back down here, so the math, now where's the math come in all of this? Well, I'm just going to give you a thumbnail sketch. Okay, the math comes into play in terms of something we call a distribution. And this is an idea that I'm going to spend a great deal of time on this semester, explaining what a distribution is. But notice, this is where algebra comes in too, because I just drew an axis and I put a variable on it. And now I'm going to sketch a distribution. It's going to be a bell curve, normal distribution. And I'm going to center that on the true population average for male human footprints. And again, I am not expecting you to understand all these details. All I'm trying to do in this first lecture is give you just a thumbnail sketch of how this works. Now, we're taught when we think about how likely it is that that footprint that was cast by Jerry Crew, how likely is it that that's a human track? What we do is we take its length. The math part of it is we compare the number in the population, the theoretical population of human foot tracks that are at least 16 inches. I'm thinking x-axis here. So what proportion out of the total of this population? And then that we can use to think about how rare and unusual this particular data point is. But in any case, this is just, again, a very quick thumbnail sketch of the ideas in statistics and how we can take a question from the world and translate it into something we can approach using mathematics. Now, it's following up on this a little bit more because very few scientists are willing to reject the null hypothesis in the case of Bigfoot. And for very understandable reasons, absolutely. But there are a few that have come forward and said, you know, I no longer think the null hypothesis is true here. I no longer believe that Bigfoot does not exist. And again, I present this to you just to give you a feeling for how statistical decision making works. And to me, it's interesting because in terms of this decision making, you can teach people like a cookbook way of making decisions. Like if one number is smaller than the other number, then you always reject the null hypothesis. And that's all well and good and easy to memorize. But I think it's more important to understand the philosophy. Now, sometimes we can take the data value and actually create, based on assumptions, this thing we call a mathematical distribution and figure out probabilities and interpret those. And that's something we do all the time in statistics. But philosophically, we could also examine the evidence in a different way. And this is not a mathematical way at all. So basically, this set of tracks convinced a scientist named Grover Krantz that he can no longer accept the null hypothesis being true. And here's why. Just give you a quick thumbnail sketch. Now, Grover Krantz was an expert. He was a physical anthropologist and a professor at a university in Washington. I believe I can't remember, I think it was Eastern Washington, but I don't remember exactly which university. In any case, what he realized is that when you take, the interesting thing about this called the Cripplefoot track or cripple track, and what he realized is if you take the normal foot, and the thing that was really unusual about it is there was a right and a left foot, a set of tracks. And Grover went in here and he laid out where all the bones should be in that foot, anatomically. And he realized that he could take apart all of these bones and rearrange them in the crippled foot in a way that made logical sense. And to him, that was so implausible that a hoaxer would have that amount of creativity and be able to actually create a cripple footprint as compelling as the one that he was looking at. And so again, he rejected the null hypothesis based on this set of tracks. Now, so philosophically we can think about this evidence in terms of a null and alternate, but then what distribution will we apply? In other words, the math part kind of gets more difficult and we have to rely on a more intuitive kind of likelihood assessment. How likely is it that somebody would have actually hoaxed these? And again, they were so large that, they're just not human. It's implausible. And I'll come back to how we would do the analysis to rule out a human footprint later on in the course when it's more relevant mathematically. And just to kind of quote these guys, just to give you a sense for, again, what I'm trying to do is point out how scientists approach this decision-making process. And the question ultimately arises, can the Blossberg footprints be hoaxes? Both Professor Grover Krantz of Washington State University and John Napier, a British primatologists, have studied these tracks and have come to the conclusion that they could not have been faked. The tracks crossed over railroad tracks and a highway, up a steep hill, and stepped over a 43-inch fence. And this is, again, this last paragraph is the main reason I bring this up is because this is the philosophy of decision making. Why would anyone go to so much trouble to create over 1,000 tracks over uneven terrain and create an anatomically correct foot deformity? As Napier puts it, it's very difficult to conceive of a hoaxer so subtle, so knowledgeable, and so sick who would deliberately fake a footprint of this nature. I suppose it is possible, but it is so unlikely that I'm prepared to discount it. That, if you read what he's saying I'm going to reject the null hypothesis because this is implausible. Again, I love this example because, and by the way, it's not because I believe in Bigfoot. That's irrelevant completely. What I believe has no bearing whatsoever on this. I think the reason it's a good statistical example is because you can take that information, follow the philosophy, and ask yourself objectively, is this track rare and unusual given there's no Bigfoot? So, and really, I believe it's up to every single individual to have the framework for how the decisions being made. but then to apply their own standards. There's absolutely nothing wrong with saying this is all a bunch of baloney too. But it's the process that I'm focused on here. All right, so I want to go through a few things from the syllabus for the course. The textbook is Interactive Statistics. It's the 3rd edition, and it's written by Martha Aliaga and Brenda Gunderson. Now, there's also another copy of the textbook floating out there. It's actually a paperback. The correct one has a spiral bound. The other one was a custom published book that we used a while back. And the problem is the page numbers aren't going to, there are a few pages that are missing, and there are also the problem with the page numbers aren't the same in the custom published. So the one you want is the spiral bound 3rd edition. You can download the first chapter by following this link. And textbooks also available at the CR bookstore, but it's generally much cheaper online. Now, there's another book I'd like you to read, and the title is The Lady Tasting Tea. Now, this is not a required reading, and what I do is I give you extra credit, and the extra credit I'll explain later on down the road. The basic idea, I guess I can explain it now real quickly as well, but so The Lady Tasting Tea is a really interesting book, and it's really a narrative history of how statistics and science sort of developed together, starting around the turn of the 19th century. And what I do basically is give you 5 extra credit assignments and ask you to write short essays. And the short essays I use as extra credit in the quiz activity category for my grading here. So let me jump into grading. So basically there's four categories for your grade: homework, quizzes and activities, essay exams, and a final exam. And I'll go through all of these here. And then this is how I weight those particular categories. So the extra credit from the Lady Tasting Tea applies to the quiz and activity category here. And then homework's worth 15%. There are 2 essay exams, and they're worth 40% of your grade. They're 20% of your grade for each one. And then there'll be a comprehensive final exam. It's worth 15%. Now, homework, very important to do your homework. Basically, the course is, I'll give you weekly reading assignments from the textbook. There'll be weekly lectures in this format that I'm using right now, and there'll also be weekly homework assignments. And the weekly homework and the weekly reading assignment and the weekly homework assignments will be posted in MyCR. Now, in MyCR, you have a Dropbox. Okay, so when you go to this course, Elementary Statistics, Olson, the virtual section, etc., when you go to your MyCR page and find that course, you'll see a Dropbox on the left-hand side. And that Dropbox is where I want you to place your homework assignments. And here's how I want you to do your homework. I'd like you to do your homework, well, you can type it up if you like. That's your choice. You don't, but it's not required. The other thing you can do is to just go ahead and use pencil and paper and then take a photograph. And you can use, your smartphone if you have one, or a digital camera, or some other kind of electronic device that can take photographs. And then, and those photographs need to be in a JPEG or a PDF file format. PDF's really preferable. And, software programs like Microsoft Word create PDFs automatically. In any case, many types of software now do allow you to export files as PDFs. And that's helpful. That makes my life easier if you know how to do that. But I will accept it as a JPEG as well. And then, so before the deadline, before the due date on the homework, you need to upload those files into your MyCR Dropbox. Okay, here's the other category: activities. I'm going to assign approximately 5 activities during the course, and some of the activities are going to require TI-83 and 84 programs. And what I'm going to do is, for each one of these programs, I'm going to make a short video going step by step through the process of entering the program into the calculator. The programs I use for these activities are not really that long, so it doesn't really take that much time to enter one into your calculator, and also kind of helps you gain some familiarity with it, with the calculator. So and that'll be down the road. I'll do that. But you can also, there's a couple other ways you can get the programs. I'll have the source code for the programs on my web page that I use for this course, and I'll send that web page address out in an email. And so so you'll be able to link to my web page and download the source code for those programs. The other option is to come by my office on campus, which is in Creative Arts. And the specific room number is on my syllabus. So if you go to my syllabus, you can find the room number. And you can come by my office, and I'll download those. I'll link them to you from my calculator. So that's the quickest and easiest way to get the programs. So that'll be an option as well. Okay, quizzes. We're going to have weekly quizzes, and they're going to be administered using MyCR's Test and Quizzes tool. The quizzes are open book quizzes, but you should prepare as you would for a face-to-face class. You're going to be limited to a total of 30 minutes for each quiz, and you're not going to have time to search and find answers. So you need to know how to do the problems, and you need to be current in the class to do well on the quizzes. So each week the quiz will be posted to MyCR, and you can take the quiz anytime during the open period. But once you start the quiz, the clock starts, and you'll have 30 minutes from that point to complete the quiz. You're also expected to follow the class code of conduct, which is on my full syllabus. I don't have it on this PowerPoint slide, but please check the syllabus for that. Okay, essay exams. I am going to assign 2 take-home essay exams. And I call them essay exams, but the first one is an essay. I encourage you to work together on these, and I'm going to require you to share ideas and critique each other's work. So one of the things about the course that I need to point out, since it's online, is that you're going to need to be able to exchange documents with a couple other people in the course, and I'll assign these groups very soon. In the first week or two, I'll give you these group assignments, and you'll need to be able to contact each other, maybe through email. There are also tools in MyCR that I'll make available that you could use, but my experience has been students tend to use email. It's convenient for them. And so, for example, I'm going to ask you to write a rough draft of this first essay, and critique and provide your essay, your rough draft. I know I'm not making sense here. I'll try to explain it better. But the idea is that I'm going to have you write a rough draft, exchange it with 2 other people in the class, and then you're going to evaluate and critique your classmates' essay rough drafts based on particular criteria that I have. And what I give you is like a form that you fill out on the other students' rough drafts. So in any case, but again, I wanted to point out that since it's an online course, you need to be comfortable communicating with each other using some electronic type medium. Final exam. Okay, it's cumulative. It's going to consist of problems that are similar to the quizzes in the short essay questions. The final exam will be administered using MyCR's Test and Quizzes tool. The final exam is open book, but you really need to be prepared again because of the time limit. You're limited to 2 hours, and I think that well, I know you're not going to be able to search and find answers in that amount of time. You need to know how to do the problems. You need to have studied, and I provide a study guide as well. So we'll get to that later. So I wanted to talk just briefly about Essay Exam 1 because it's a major part of your grade, and it's something that you really should get started on right away. Okay, so what I want you to do is I want you to be looking for a media article. And a media article is something from a newspaper, from the internet maybe, or from a magazine, and those types of things. Like, what do you think, like Gentleman's Quarterly, or what are these magazines? Sunset, I don't know. I don't read magazines. But in any case, those are like what I would consider media. Now, and what you're looking for is a media source, a newspaper, a magazine article that's citing or that's about some scientific statistical study. And again, this will be your topic for the first essay exam. And again, I'm going to talk more about this later and give you more details. And you'll be able to find, you can actually link to and find the assignment on my web page. And I'll put the information for how to get on my web page in my CR. So you'll be able to do that, no problem. All right, well, that's the end of this lecture.